Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 3.5 Quadrilateral Properties. By the end of this lesson, you will understand and know the properties of parallelograms, rectangles, squares, and rhombi. Why do you need to know this? Well, understanding that a shape can be more than one of the special quadrilaterals is important to identify and construct those shapes. How will you know it? I'll know I mastered it when I can use the properties of special quadrilaterals to identify and construct different shapes.
All right, let's go ahead and get started. So what is a parallelogram? A parallelogram is going to be a quadrilateral whose opposite sides are parallel, or you can think of it as two sets of parallel sides. So for this quadrilateral here on the screen to be considered a parallelogram, we would need to know that sides AB is parallel to DC and side AD is parallel to BC. So it would look something like this. Once you know you have those two sets of parallel sides, you are able then to be more specific to say a quadrilateral is a parallelogram. To name a parallelogram, you're going to use all four vertices, and you're going to start at any vertex you'd like and then go clockwise or counterclockwise around the shape. So for this one here, you could name this as ABCD or ADCB depending on which direction you decide to go in. Let's talk about the different properties that you're going to see when you have a parallelogram. The first is the opposite sides. So opposite sides of a parallelogram are congruent. Opposite sides are the sides not connected. So you can see that AB is not connected to DC, so therefore AB would be congruent to DC. Also, AD is not connected to BC, so they would be considered opposite sides, making them congruent if you have a parallelogram.
Next, you have opposite angles. Opposite angles of a parallelogram are also congruent. Your opposite angles will be diagonal from each other. So in this case, angle A is congruent to angle C, and angle B is congruent to angle D.
And next is actually a review from section 3.1 earlier in this course. Consecutive angles are supplementary. So consecutive angles is a new vocabulary word. However, we called it something else in lesson 3.1. They were called same-side interior angles. So if you remember, by definition, a parallelogram has opposite sides parallel. So we know that AB is parallel to DC, which makes AD a transversal, making angle A and angle D same-side interior angles. Consecutive angles in a parallelogram are just angles that go right next to each other. So angle A, angle D would be consecutive. Angle D and angle C would also be considered consecutive. So we are able to make the equation that they add up to equal 180 degrees. And the same pattern would go around. C and B would be supplementary, and B and A would be supplementary.
Now we have our diagonals. Your diagonals will bisect each other. To bisect each other means they are cutting each other in half. So the diagonal DB will cut in half the diagonal AC, making each side of the diagonal congruent to the other side. So we could say that AP is congruent to PC and DP is congruent to PB.
Okay, so using these properties and the definition of a parallelogram, we now have 5 ways we can prove a quadrilateral is more specifically a parallelogram. So we have a blank spot for you to write in each one. If we were ever to ask you to prove a quadrilateral is a parallelogram, one way you could do this is to show that you have 2 pairs of parallel sides. If you have that, then you have a parallelogram. The second way you could do this is if you can prove that both pairs of opposite sides are congruent. Once you've done that, you can say that you have a parallelogram. The next one is a special one. I'm going to ask you to put a star by it. It's basically a combination of steps 1 and 2. So if you can prove that one pair of sides are both congruent and parallel, so again, it's a combination of step 1 and 2, that is enough to say the quadrilateral is a parallelogram. Next, if you are able to prove that the opposite angles in your quadrilateral are congruent, that is enough to have a parallelogram. And then the last, fifth one, is the last property we discussed. If you can prove that the diagonals bisect each other, that is enough to say the quadrilateral is more specifically a parallelogram. Once you have these 5 listed, please go ahead and turn your page. Now we're going to talk about more specific types of parallelograms. The first one is going to be a rectangle. A rectangle is a quadrilateral that has 4 right angles. A rectangle, because of that, has all properties of a parallelogram. If you remember back to the front page, if you have a parallelogram, you know the opposite angles are congruent and the consecutive angles are supplementary. Well, if all of your angles are right angles, it fits that criteria. So angle A is congruent to angle C. Angle B is congruent to angle D. So therefore, this is a parallelogram. So all of these characteristics down here at the bottom that we wrote on the front side that deal with parallelograms are able to be used when we are talking about rectangles. Now, a rectangle is a more specific type of parallelogram, so therefore there are some new characteristics that you guys need to write down. One of them is, if you have a rectangle, parallelogram is a rectangle, then you also know the diagonals are congruent. So in this picture here, you can see the diagonal is AC. A diagonal is when the opposite angles connect. We would be able to say it is congruent to BD if this were a rectangle, which we already established it is. Because the diagonals bisect each other, you know this is a midpoint based on this criteria right here. Now you know the entire length is the same, so what we're making is a bunch of isosceles triangles here, which opens up a whole new can of worms for things we now know about the angles within our rectangle.
Absolutely.
Okay, next.
Our next one is a rhombus. A rhombus is a quadrilateral with 4 congruent sides. A rhombus also has all the properties of a parallelogram. Now, in addition to that, we have opposite sides are parallel. We will also be able to say that opposite sides are congruent. Opposite angles are also congruent. And consecutive angles are supplementary. So angle A plus angle D equals 180 degrees. Or I guess I should say angle BAD plus angle ADC is 180 degrees. Your diagonals will also bisect each other.
Now, because a rhombus is a more specific type of parallelogram, you also know these 2 things. If you have a rhombus, you are able to say that the diagonals are perpendicular, which means you know these 4 angles form right angles. You also are able to say that each diagonal of the rhombus bisects the pair of opposite angles. So because the opposite sides are congruent, we know that this is a parallelogram, which is why we listed that opposite angles are congruent. So because of this, we actually know that each of these 4 angles are congruent, and each of these 4 angles are going to be congruent.
So, for example, on your picture, angle 1 is congruent to angle 2. Angle 4 is congruent to angle 5. And angle 3 is absolutely a right angle.
Okay. And the last special kind of parallelogram we're going to look at is a square. A square is a quadrilateral that has the most characteristics because it's the most specific type of parallelogram. It is a quadrilateral with 4 right angles and 4 congruent sides. So it actually is a rectangle and rhombus put together. So you know that these 4 angles in the corners are all right angles. You also know that these 4 sides are congruent. Because you know that squares are parallelograms because the opposite sides are congruent and the opposite angles are congruent. So for the third time now, we have what you would consider a different shape actually fitting the criteria of a parallelogram. Now, because we know that a rhombus has to have 4 congruent sides, a square is always going to be a rhombus, which means we know that these angles are being bisected. Well, I know by definition that originally they were 90 degrees. So these complementary angles are actually going to be 45-degree angles. All 8 of them are going to be 45-degree angles. Also, because you know that because you have the 4 right angles, you also know that these diagonals are congruent because that's a characteristic of a rectangle. And by definition, a rectangle is a quadrilateral with 4 right angles, which a square is. So squares are always rectangles. So there you go.
Now, another thing you can think of is when you were looking at a rhombus and trying to figure out the difference between a rhombus and a square. The easiest way for me to think of it is a rhombus is a square that somebody gave a little bit of a push to. So it's like somebody pushed my rhombus over a little bit.
Same with a rectangle and a parallelogram.
Yes, same with a rectangle and a parallelogram.
The opposite sides, they're going to be a little longer than...
Right, so if I take a parallelogram and I give it a little bit of a push on the top side and shove it over, it's going to look like a parallelogram. Same thing with your square and your rhombus. Yep, good.
All right, so let's go ahead and work through some examples. So the first 2 problems are in the parallelogram box, so we're implying that these are 2 parallelograms. So to approach these problems, you have to think about the property that Mrs. Netz and myself are pushing you to use here. So if you look here, hopefully you're clearly seeing that we're talking about the sides of the parallelogram. Well, we wrote 2 things down about the sides of a parallelogram, that the opposite sides are parallel and the opposite sides are congruent. You can't really make an equation to solve for a variable using parallel lines, so we're going to use that opposite sides are congruent. So if you look here, that means that 6x is opposite the 4x plus 8, so therefore they must equal each other. Y plus 2 is opposite the 2y, so therefore they must equal each other. So that's where we're going to start. 2y is equal to y plus 2, and then you're going to use your properties of equality to go through and solve this. So the first thing you would do is subtract y from both sides, and you would end up getting that y has a value of 2. As I said earlier, your x's are equal to each other because they are opposite. So therefore we can say that 6x is equal to 4x plus 8. You can use the subtraction property of equality to get 2x is equal to 8. And then if you divide by 2 on both sides, you end up getting an answer of 4. For the parallelogram on the right side of your notes, hopefully now it's clear we're talking about the angles of the polygon, or I'm sorry, of the parallelogram. So there were 2 things we wrote down. One was that the opposite angles of a parallelogram are congruent, and the second was that consecutive angles of a parallelogram are supplementary. So we're actually going to use both. The first, to solve for x, you can see that x is opposite 120, so therefore we know they are equal. So we can go ahead and use the subtraction property of equality, subtract 8 on both sides, and you end up getting 2x is equal to 112. Then using the division property, we end up getting a value of 56 for x. To find y, you can see that 5y is consecutive to 120. So therefore we know that 5y plus 120 would equal 180. Using the subtraction property, we get that 5y is equal to 60. And then lastly, the division property is going to give me a value of 12 for y. Moving on, we're now going to look at rectangles.
This one is a little bit of fun, I personally think, but maybe I'm just mathematically weird. So we're first going to start off with if AE is 3x plus 2 and BE is 29, find the value of x. So I would recommend labeling your picture. Your picture is a lot bigger than ours, so I would recommend labeling it. Ours is not labeled because it's kind of hard to write with a big pen on a tiny picture.
Yes.
So go ahead and label AE where pretty much where it says 2, you're going to label that 3x plus 2, and then where it says EB, you're going to go ahead and label that 29. So we know, because this is a rectangle, and we also know by the properties, we know that they are all isosceles triangles inside the rectangle. So since we know isosceles triangles, both of the sides are congruent, we're going to say that 3x plus 2 is equal to 29. So since 3x plus 2 is equal to 29, I can say that 3x equals 27 and x equals 9. Then next, what I can do is I know that AC is equal to 21. Well, if AC is equal to 21, then BE has to be equal to 1/2 of AC. The reason I know this is because I know AC and DB are equal. So since they are equal, I can take 1/2 of AC, and that will equal 1/2 of DB. 1/2 of 21, 1/2 of 21, 1/2 of 21 is 10.5. Next, we have, if the measure of angle 1 equals 4x, and the measure of angle 4 equals 2x, find the value of x. So what we are going to do is we are going to go ahead and do some substitution. So first of all, the measure of angle 1 is 4x, and I know the measure of angle 4 is 2x. Well, I know there's actually another angle 1, kind of, as another base angle on the other side of the triangle. It has to be congruent to angle 1. So my value for angle 1, I'm actually going to add twice. So 4x plus 4x plus 2x all equals 180 degrees. So the next thing I'm going to do is I'm going to go ahead and simplify, and I get 10x is equal to 180, and then x is equal to 18. Lastly, I have, if the measure of angle 2 is 40 degrees, and find the measure of angle 1, 3, 4, 5, and 6. Now, this may look a little overwhelming, but to be honest with you, it's actually really not that bad. So what you're going to do is you're going to go ahead and label angle 2 40 degrees. Once you label angle 2 40 degrees, you know that angle 1 plus angle 2 is 90 degrees. So what plus 40, or what is the complement to 40, and that is 50. Next, we have angle 3. Angle 3 has got to be the same thing or congruent to angle 2. So that makes angle 3 also 40 degrees.
And why are they the same again?
They are the same because inside the rectangle we have all of these isosceles triangles, and those are both the base angles, or you could say that the diagonals are cutting those angles the same on it. So angle 2 and angle 3 both end up being the same because both of those diagonals are coming in basically at the same slope. Okay, so now next thing we have is angle 4. Angle 4, if you look at it, basically it is going to be the difference between 180 degrees and angle 1 and our unlabeled angle in triangle AED. So
We already talked about how this angle is the same as this angle. So we know angle 1 is 50, so 50 plus 50 is going to give me 100.
So angle 4 has to be 80 degrees. Next we have angle 5. Well, if angle 4 is 80 degrees, and we look at angle 5, Angle 4 and angle 5 are a linear pair. Our students really don't like that vocabulary word.
I know, I don't know why.
It's two angles that make a line, linear pair. Anyway, so they are a linear pair. So that makes angle 5 100 degrees.
You could also, just to tie in something from lesson 3.2, you could have used for both angle 4 and angle 5, you could have used the exterior angle theorem. You know angle 5 is an exterior angle to this triangle. Well, you know these two green ones are 50. So 50 plus 50 is 100. You also knew angle 2 and 3 were both 40. Well, what's 40 plus 40? That gives me the exterior angle 4, which we already said was 80.
Yep. Last, angle 6. Well, if you look, angle 6 is somewhat of a reflection of angle 2. Because if you look, you have a triangle AEB, and it's reflected, and you can see triangle DEC. So angle 2, it's got to be the same thing as angle 6.
You could also, just to look at it at a different perspective, you know AB is parallel to DC, so therefore angle 3 and 6 are alternate interior angles, so you knew they had to be the same.
So many different ways to solve this.
Yes.
All right, let's go on.
Okay, now we're going to look at a rhombus. So think about the properties of a rhombus. It has to have 4 congruent sides, all the properties of a parallelogram, the diagonals bisect the angles, and the diagonals are perpendicular. That's everything we have written down. So if AB is 9, AB is a side of my rhombus, what would AD be?
Well, let's remember, a rhombus is like a square, just it's been shoved over. So all the sides have to be the same.
So therefore AD must be
9.
Next, angle 1 is 65 degrees, so therefore angle 2 would be what? Well, if we're looking at this, angle 1 and 2 are both up here by vertex A. If you remember, we just talked about this. We know AC, the diagonal, is bisecting angles A and C. What does bisect mean?
Cut in half.
So therefore 1 and 2 must be the same. Ta-da!
Yay! Angle 3. Well, angle 3 is in the middle, and we know that with a rhombus, our diagonals are going to be perpendicular. So because they are perpendicular, I know that angle 3 is 90 degrees.
Okay, angle ADC. So angle ADC is going to be right here, ADC, is 80 degrees. It's asking us to find what angle DAB is. Well, DAB is right here. So this is not a property of a rhombus, but we know that rhombuses are always parallelograms. So angle A and angle D without the diagonals there are consecutive to each other.
And I know consecutive angles are supplementary.
So therefore, the supplement of 80 is 100. Okay, moving on.
So now, if the measure of angle 1 is equal to 3x minus 7, and the measure of angle 2 is equal to 2x plus 3, then what is x? Well, I know the measure of angle 1 and the measure of angle 2 are equal to each other because they have been bisected. So I can say that 3x minus 7 is equal to 2x plus 3. When solving, I can then say 3x equals 2x plus 10, and simplifying, I get x equals 10.
Okay, and then moving on to the last examples when dealing with squares. So squares have everything we learned today. Everything you learned about parallelograms is true in a square. Everything you learned about a rectangle is true about a square. And everything you learned about a rhombus will be true about a square. So if AB is 10, what would AD and DC have to be? Well, a square has to have 4 congruent sides.
So wouldn't that mean the answer to both of these is just 10?
Correct. And I don't know why we didn't ask, but what would BC be?
10.
All right, number 2, if CE is equal to 5, what is DE? Well, remember, a square is a rectangle. So if a rectangle has isosceles triangles, so does a square. So if C to E right here is 5, then D to E must also be
5.
5.
Now we're looking at the measure of angle ABC. Well, the measure of angle ABC is that entire angle. And we know that when you have the interior angle of a square, the measure of that angle is going to be 90 degrees.
Angle ACD, I'm going to go ahead and trace this. So A to C to D, here's A to C to D, is this angle 6 right here that it's asking for. So that's not going to be 90 degrees because angle BCD is my 90 degrees. Remember, a square is a rhombus. So therefore, I know that AC is bisecting the original angle C, which I know was 90 degrees. So this angle 6 right here is a bisected angle that originally was 90. So half of 90,
45.
there you go. And the very last problem we are going to look at is angle AED. So again, I'm going to go ahead and trace this so you guys can see it a little bit more clearly. Here's AED. Well, because I know a square is a rhombus, I know the diagonals must be perpendicular, and I already knew coming in that perpendicular is when two lines intersect and form right angles, making this a 90-degree angle. And that is the conclusion of our lesson. Hopefully you feel that you can identify and use the properties of these special quadrilaterals, parallelograms, squares, rhombi, and rectangles. If you have any questions about today's lesson, please reach out to us on Remind or email us at the emails you see on your screen, or reach out to your teacher.
Hey, Mrs. Weichel.
Hey, what, Miss Nets?
What do you call an angle which is adorable?
What?
A cute angle.
Aw, that's so cute.
Oh,
Aw.
gosh.
Thanks for joining us.
We'll see you in
Chapter 4.
later.